Welcome and thank you for watching this video of our ONFB XP Lab, second edition. The Lab is an initiative of the Animation Studio where we invite creators to submit a research project or an experiment, something that they really want to try but don't have the equipment or the expertise to realize on their own. In this video, you will see the results of the 5 projects that we have selected for this year. And at the end, a discussion with the participants in the team. Enjoy the program.
The project I'm proposing for the lab is actually combining different worlds that I want to create using the Unreal Engine, 2D animations, and some live action footage for the characters. And basically, because I've already tested, because I've already worked with 2D medium and with live action, so I think the base of this experimentation with the NFB lab is going to be concentrated on the on creating the world I want in Unreal Engines.
This project has been going on, we'll call it the Mantra project, which is now a new division of the company. We started this about 2 years ago, and the idea was basically to take all of the sounds and all the research and development that we've had going on for the last decade and encapsulate it in a playable form. But the thing is that we didn't want to just do a normal virtual instrument. We wanted to do something that would feel a lot more intuitive and take a player somewhere else, and also in a sense also build in some of the video game kind of methodologies and sensibilities that we've developed over the years as well. So we basically created a non-linear musical expression engine that's very powerful and able to do many things. But we also had in mind with this to have very simple controls that would allow people to do intuitive expression in a very easy fashion.
So usually when people 3D scan an object, the goal is to have the most precise scan at the end, so the object is static. I was wondering what it would do if you move during the scan to kind of fool the sensor. So there's this part, and there's also the part of exploring the limits and the limitations of technologies to push them at their breaking edges to see what we can gather, what we can get. Can we get some interesting things? Kind of the equivalent of feedback or fuzz in music, which were effects that usually you try to avoid, but you can also take them and use them for creative purposes.
I guess I was sort of still relatively new to VR, and I really wanted to explore how various VR creation tools could be sort of worked into my existing animation workflow. So another aspect of the project was, how can we use VR to, I guess, what tools and techniques in the game engine can we use to mess with perception, doing things with shaders and physics and deformation, to take a solid reality and then to make it something else, alive and fluid and dynamic.
We try to do, this for real-time visual effects, but why not, try to have it actually done with a real animation, a real character, or something, a rig that animators use, so we could actually sit down with them, or virtually, to see if does it work for you? Is it convenient? Is it useful to do it in real time?
My name is Parisa Mohit. I'm a filmmaker and animator working in Montreal. I switch between my directing and producing my personal films and collaborating on other film animations as a designer, animator, or visual artist. I'm also a co-founder of an animation collective in Montreal, which is called Astroplastic.
My project is an investigation for combining different environments created with Unreal Engine with live action footage and 2D animation. I intend to use this experimentation from this lab to develop my knowledge of Unreal Engine and to kind of use this workflow and pipeline for the production of a narrative short animation film that I have in mind. I come from an animation background, but a 2D animation. I have never touched 3D software, basically. What I was always feeling restricted in the way I could create them. I was trying different ways. I was building sets in a hope that I can get more and more close to a semi 3D world that can help me move faster and more fluid and with more freedom into the space. But that also had its own limitations. So actually what inspired me was to kind of have the best of all these worlds, like the best of possibilities that 3D camera movement environment can offer to me, like possibilities that a live action shooting with an actor can offer to me, and also, of course, all the possibilities that the animation cinema and the hand-drawn animation already gives me. So I wanted to have the best of these worlds, and mix them together. So basically, my first step was to create the base of the world. My knowledge in Unreal Engine was very basic, but and I knew that I don't want to spend time learning to model stuff. So I found a prefabricated world that was close to what I had in mind. And I actually really love this process because to me it was like a location hunting or location scouting for like a live action film. So when I created the world and I set up the camera, I started shooting a bit in the structure. And actually at this point, I became a bit blocked. The fact that I had already like a story and a film in mind, and I wanted to kind of use this experimentation to help me with the pipeline for this film became like a trap at some point in the beginning. So I wanted to create exact frames that I had in mind. So I couldn't really decode and get rid of my 2D formatted mind, and I had to reboot it with a 3D mentality. Actually, what I did during the residency was building this environment, shooting my character, which is actually myself, who's gonna play the role of the main character. I'm still working on an integration, but that's not what I want to talk about because that's like still something that I think I might even end up doing it in After Effects because Unreal might not be the best engine. One of my big surprises and big discoveries was facing like the possibility that the material and shaders can give me, and actually to realize that what I really need for this film is the material, is how my story is going to be told through the materials, the way they reflect through each other, and also the way that they interact within each other and with the characters. What I am planning to experiment more with Llewellyn, who is my mentor, is to really go study deeply how to create different materials. My approach in the very beginning of writing that proposal was that, okay, that's going to be a technical experimentation lab for me, and I was seeing this software as just a technical tool, while working and talking and discussing through these past weeks with Llewellyn and Eloi helped me see the whole potential that this environment can give me in terms of investigation and in terms of research. Also, I was discussing with Llewellyn, and he kind of reminded me and made me think that still the way that I'm working with this software is as if I'm working with a 3D software, let's say like Maya, and that I should really try to consider more and more like the real-time capacities and that this Unreal can offer me. So this is also like the next step that I'm going to experiment. and we'll see where I go from there.
Yeah, there's still some research, like it opened up new ways, like for example, like the texture, even the importance of texture and everything in my work, and the fact that textures were not working the way I wanted to, like especially the reflections, that like the whole idea of my project is based on the reflections of objects or of materials into each other, but it doesn't work as easily as I was imagining. So that's what we're working from now on. And then yes, also the integration of all these worlds are still like a work in progress. But anyway, like one of the main reasons I chose like this to test this workflow is because, as you said, like I want to make frame by frame films, but I want to have the good things of the world of live action, because that's how I'm trained and I'm used to see the world. So I'm always, anyway, I always have that part of my mind and my eye that is blocked, because when I animate and I draw, I only have a 2D dimension. So that's what I want to have as a base of creation, to kind of create and film in a 3D world that is kind of handmade and closer to the realism, the way I see the world, and then to kind of mix it with my mediums. So kind of use the tools that I'm more comfortable with.
Great. So my name is Brian D'Oliveira. I'm the CEO and founder of Lahassina Creative, and also Mantra, our new instrument and advanced audio tools division.
Hey, I'm Noah, and I joined about 6 months ago onto Mantra as the designer, taking care of all the product design and branding and various tasks around that.
So this is Mantra. We have been at it for about a year and a half, and we started with the original idea of wanting to create a new musical instrument that would have a lot more expressivity than a normal instrument. As you can tell here, we're surrounded by over 1,200 instruments, and because of this experience with playing instruments every day, we kind of don't actually like to be playing with virtual instruments, but it brought about the idea of like, what if we could make a virtual instrument that we would enjoy playing, that we would actually be able to use just as expressively as the instruments that we play here. So the great thing is that we actually work with video games quite a bit, and we got the inspiration to look at it from the perspective of what if we could actually create nonlinear sound, nonlinear expression, which is something that's inept and built into all of these instruments. There's a randomness, there's a magic to it. And so we created this engine, this audio engine that basically does that. We have taken sort of the nonlinear sound design aspects of a game engine, built it into a VST application, a virtual instrument application. But after doing this, we realized there was still something very key missing, and this was the interfacing aspect of it. How do you express a nonlinear form of expression and sound parameters, where you could have literally hundreds of parameters happening at the same time just by having one single movement? So we realized that we needed to get away from the usual way of setting up an app, which is using parameters and knobs and numbers, and really go somewhere else, somewhere new. And this to us was natural to think about animations and trying to think of creating a visual metaphor for the sound, that expression that we're creating. So this is where the XP Lab came in very handy for us, because we started with something very basic here. If you want to zoom in here, this is our first sort of prototype where we just use simple shapes. So we built our engine based on 3 axes. There's X, Y, Z. So this parameter here that you see that's a triangle is Y. The other parameter here is X. So you've got the sideway movement. And then Z would be depth. And this is how we were for quite a few months. And with the XP Lab, what started to become very interesting was to actually put in actual animations in there, and we worked with Brandon Blommaert for quite a bit, and this is one of the sort of ways that he thought about representing each of these axes. As you can tell, the figure was one. The other side was also the z-axis, and the lines on the side here are the x-axis. The one thing was that we discovered very quickly that we had quite a bit of limitations to work with. We had to create an audio app that's very efficient, but also try to work in this visual stimuli. So this whole process of going back and forth and also testing within our application, we realized that we just needed to go more minimalist, very line-based, and actually we're using SVGs and Lottie-based animations. And at this point we have something, after all this experimentation, actually, we developed something which is closer to this. And this is still a work in progress. This is a new instrument called Atma. And as you can see, I'm using a leap controller, and I'm moving my hand, and the parameters are moving. So for example, if I play something, so you've got the axis, I'm gonna change I can change to the other sound. So yeah, this is kind of the state of affairs where we're at right now. I think there's gonna be quite a bit more that we're going to continue in the next few months, but having this foundation of being able to just go back and forth, workshop it, put it into the app, see how it feels, it's actually opened up a lot of doors for us, and we think that with aesthetic that's working. We've had actually quite a few people react to this. We already have over 500 users, and everybody's really very satisfied with using this kind of interfacing instead of just like 3 knobs. So yeah, that's pretty much it. We've basically hit that goal. We have a defined, solid foundation, and then we're going to keep on building from there. I don't know if you want to add to this, Noah.
Yeah, I think just some of the team here has been working on this project for like 2 years without a real push publicly or showing it to people. So just being able to show some like-minded creators what we've been up to, I think is really exciting for the whole team.
My name is Alexandre Roy. I'm an independent animator and visual artist. I've been working in the last 20 years in a myriad of techniques, from sand on glass to 2D computer animation. In the last few years, I've done mostly paint on film, paint on 35 film stock films, and also work on pin screen. So my name is Alexandre Roy. I'm an independent animator and also visual artist. And what interested me in the lab is to try to recreate something I did with a flatbed scanner, which was, and I'm going to share screen, which was moving either my own hand or object on the scan while the light was coming. So it gave what's called a slit scan effect, where the scanner doesn't care what's in front of it. It just takes where the light is at that point. So it's possible to do really weird manipulation straight on the window. That was the first thing that gave me the idea to think, what if I could do that in 3D? So would there be a way to have this kind of image, but to have actually a mesh that you could either animate or turn around? And the second thing that was interesting to me was kind of so these are other examples of more objects that I manipulated on the scanner. The other thing was Norman McLaren's Pas de Deux movie, where he used video or film echo to kind of record all the steps of one movement. So you have this trail that follows the movement. And this was also probably inspired by Etienne Jules Marie, who was a pioneer of cinema, who did photos where he exposed all the phases of one movement on one plate. So you get, again, that trail. So the idea was, is it possible to move during a 3D scan and to have that kind of effect? And the first answer is no, it's not possible. It's possible to move, but what we learned during the experimentation, first with a small scanner, turntable scanner, and afterwards with Kinect, is that, and a hand scanner too, for 3D scanning, is that most scanning software are idiot-proof. So when you move, the software thinks, stop, you don't want to have those beautiful trails, it's going to be an error. So the scanners simply stop and asks you to stop moving either the scanner or the object. So the first step was, well, actually it doesn't work. First workaround I found is with that scanner, there's a rotating plate, and you can take multiple scans. So by moving the objects in each scan, I could have some kind of layering of movement. So I started with that. And the first thing I tried was my hand. So the first thing I tried to reproduce was exactly what I did on the scanner. So it was literally my hand that I moved. And it gave something, but the thing we found out through all the process was it's really hard to have something that's usable. Either it gives nothing or it gives a kind of jumble that often doesn't resemble anything. So the process has mostly been to trying to find a way around what the computer wants to do to get to what I actually want to do. So this was really my first try. And then afterwards, I continued like doing that. And what's really nice with that project is, even though my main goal didn't really work until up to yesterday, it really opened a bunch of other directions that were in fact really interesting. One of these was to put many objects on the turntable, and by moving them and doing the global mesh at the end, it became kind of a molded jumble, which was really interesting and had some kind of decayed post-apocalyptic object feeling that I really liked. So one of the thing I tried, so this, and afterwards I started feeding textures in these kind of weird objects that are really like a mix of things. So this is a core of a 35 film reel and a fan to pull yourself. So I've got here the straight one, straight. So this is without the texture. That's actually what the computer was able to understand of what I put on the scanner. So this was one way, one avenue that I really liked. And then I also tried to use more organic things like lobsters or shells. So again, you get these kinds of really weird shapes that are, I really couldn't really do something precise. It's kind of a roll of the dice and you get what you get. But afterwards, you can do some really interesting things with that. So that was kind of the middle of the experimenting, where I was also learning Blender while doing that. Another avenue that I really liked is I tried to create some plasticine characters to scan them. So you have the really organic feeling of the plasticine, but you get also the really soft the 3D digital feel of the scan. And again, you can feed like what you want in the textures, and you can see in that character, one of the thing I didn't know was happening is the character were moving a bit when I was scanning them. So you kind of get the slices of how they were waving during the scan. And so these, this is another kind of weird, and also I started using these 3D models to rework them more as images in Photoshop, and working like sometimes doing my own rejumbling of these images to create some kind of weird structures, and also taking some pixels and extending them to again create that kind of post-apocalyptic feeling. And I like sometimes the errors, like in this one, the mesh at the bottom was kind of scrapped during one of my manipulation, but I like how you can actually see inside the object. And yeah, and I work with these kind of weird meshes to create images that were really not what I was intended when I started, where I was really wanting to capture more a movement. So that would take us to tomorrow, yesterday, in fact, where we kind of found a way. We found something that was a promising avenue that looked like what I was trying to get by using many Kinect cameras, but without syncing them. Because what happens also that I learned during the process is some scanners will let you scan the movement and you actually see it while you scan, but afterwards it still goes behind after you and cleans up, thinking that all the movement trail was an error. So if I move my hand in front of the floor, it's gonna go see in all the other frames where my hand wasn't there to erase it. So that's really not what I was wanting to do. So yesterday, what we found is by using 3 Kinect cameras, but not syncing them, the cameras doesn't know what's right and what's wrong. So it doesn't know what to erase. So it kind of keeps some of the motion trails. So we started to have some trails that look like what I was looking for. And it seems to be like the avenue that we can explore and really try to tell the computer, do not erase anything, keep all the points, and we'll play with them. So we got many, and these are really starting to look like what I was intending. And sometimes they do really freaky things that also, that's the other path that emerges, the creating sculptures. I think these would be really amazing, reprinted in 3D, and maybe with another texture printed on the sculpture. So this is an interesting avenue. And then you get like really trippy stuff. This was by taking a really longer exposure, so you kind of see the motions that, if we come back to the start, that I was looking for. Like this is the closest that we've been to actually finding a way to record a movement. And the other thing that was really interesting, and I think I'll finish with that, is at the start, what was interesting for me, either on the flatbed scanner or the 3D, is to reintroduce some humanness and some idea of performance in a medium that's really used usually to be really clean and precise, and to have that kind of aleatoric and randomness that a performer can do in space, and to record that with that medium, and afterwards you have that really precise image of an imprecise and random process. That's really one of the things that really interested me. So that's where we are right now, and I'm really happy of all the steps. Even the mistakes were really, really interesting for me. Well, the next step will be to try with scanners that don't stop recording when something moves. So I've got two here to try with hand scanners, and I've got the videogrammetry studio at the NFB that I also want to try. And this is closer to what I submitted, but also like the image I always come back to, that kind of strangely got to me during the process of Norman McLaren's Pas de Deux movie, where he used the video echo to record, in a way, all the arcs of movements. And I'm also working on a film using Edward Muybridge's loops that he did in chronophotography. So it's kind of the same ideas of keeping all the stages of the movement on the same image. And that's something that could be really interesting to try for a dance, 3D dance video or film.
So, well, I'm Sergey. I'm an affiliate prof here at Concordia. I also manage professional things related to networking within Gina Cody School of Engineering and Computer Science, and I teach, including computer graphics and other things. So we had this project going on early on for motion capture and to basically put it on stage. And then at some point it became not really maintainable or easy to switch devices. So I organized a group of students for this project to lead an open core of a framework to do motion capture and data delivery into various applications. So that's my principal role in this lab. And I do co-supervise these two lovely students, Jonathan and Kyle, with Dr. Modor, as a part of the 3D graphics group here at Concordia. Yeah, so that's basically my brief introduction.
My name is Sudhir Mudur, and I'm a professor in the computer science and software engineering department in the Gina Cody School at Concordia University. I joined the Concordia University about 19 years back, and when I joined, I set up the 3D graphics lab.
I'm Jonathan. I'm a student and teaching assistant at Concordia's Gina Cody School of Engineering.
Hi, I'm Kyle, and I'm a full-time teacher at Collegian and Gros. I also teach part-time at Université de Sherbrooke, where I specialize mostly in using Unity to teach computer science and graphics, animation, and game design.
So we'll present our experience at the UNFB XP lab with an OpenISS project, specifically a Unity plugin for VFX and motion capture. So that's just a quick project summary. It's a mock-up framework that we're working on, and for different applications in HCI and VFX industries. And specifically, we're doing a Unity plugin with aspirations to go to Academy Software Foundation. So we're going to publish all of that in that URL on the GitHub below. Let me introduce the team briefly. So we have graduate students, Kyle and Jonathan, right here with us, doing research in various aspects. and the two supervisors, myself and Dr. Mudur. And we thank our mentors, Eloi and Luke. We actually also have an extended team because I'm teaching a class, so we have work a lot with students who do other things related to the project that we actually can incorporate as we go. So we are very agile in this. So a little bit of background. As I mentioned, it's a motion capture data delivery framework to move it to applications for specifically visual effects or other applications, and different specializations frameworks exist in the library for personal identification, gestures, faces, and so on and so forth. So some of our previous students contributed different backends to that using machine learning and whatnot. So for example, facial landmarks and emotion recognition. This is person re-identification on stage and green screening. As well as the gesture tracking framework done by Chash, because some of that work is actually John will be using. So this is a quick layout of the whole system, the whole framework. So you have applications on the left, the specializations on the right, and something, the middleware in the middle. And then this is what we provide to all of these applications, the specializations. Some engineering part to it as well. If you especially want to deploy it in the context of network, we use ROS to deliver the data and different data gesture tracking informations. So some of the applications that we do is with visual, with effects, graphics, artistic applications such as installations and others. So that's why we actually had a number of students doing it. And Costa in this case was also doing web services with the team. So we could also deliver this data over a RESTful API as well. And we tested it on a District 3 with decorating real time in a browser window or educational activities. So something like this we've been doing at conferences and other events. So I'll skip this video. Now, what are we focusing here is specifically a Unity plugin to deliver different frame data and skeleton data into the application. So skeleton is important because you can attach it to rigs. So there are different types of joints that we use. And we began our journey with a null framework. That's something that you present to generate some type of data that you could actually reliably test with, and then move on to devices, for example, Connect for Azure that we got from ONFB. So thank you very much. So we're working with that. And that's type of joints or actual images that produced by the null framework, including by the students that we work with, that we could actually import into Unity. So it has a simple API of reading frames, getting all this human body data, and a specific specialization of the Connect for Azure. And now hand over to Jonathan.
Hi, I'm Jonathan. So like Sergey said, I'm going to be helping with integrating gesture recognition. What I'm actually researching is activity recognition, which you could think of as like a generalized version of gesture recognition. So it would be like the whole body and multiple gestures. But for the XP lab, I'll be trying to integrate just gestures so that we can get a working plugin done. And hopefully by the end of my research, we'll have like some kind of VFX production application with it. And our proof of concept project for XP Lab is going to be with Unity, which I'll pass it over to Kyle to explain.
Hey everyone, I'm Kyle. So we started out this experience by talking with Eloi, our mentor here at the NFB, and we decided that Unity is something really important for our project because there's a huge user base and there are so many similar type of applications that are being driven with a Unity plugin. So that's one core part of our project here at the NFB, is to develop such a plugin as mentioned previously. Now, we started out by asking a few questions. We started with our initial phase of gathering some information and doing a few surveys. And we came to this fundamental question: should we develop this plugin as a library-based solution or a server-based solution? So we surveyed some similar plugins by Intel, Microsoft Kinect, NuiTrack, and OptiTrack. And by surveying these and their functionalities, how they were developed, their code and whatnot, we discovered that the first three in this list are library-based. So we decided to go with that. And we also weighed the pros and cons for our knowledge, our expertise, and what we actually already have developed. And library-based seemed like the best solution. For us, it was faster to implement. There's no server client overhead. And as an extra bonus, it develops a full OpenISS C# wrapper, which is independent from Unity, meaning that we can now use OpenISS in any C# application. And we do this generation of the wrapper through something called Swig, which we already do and have some knowledge about and experience with, because that's how we develop our Java wrapper. Now, there are a few cons to this library-based, like dependency management and larger file sizes. You need different libraries for each specific platform, like Linux versus Windows versus Mac. But for now, we can handle those cons. We do want to develop the server solution as well to test furthermore. And yeah, this wrapper was a great success. I'm quite happy with it. So we have 90% of OpenISS functionality working correctly in C#. Our unit tests are passing. We haven't tested on Mac, but Linux and Windows builds are working just fine. And since most of us are educators, professors, or teachers, we plan to use this in our courses where C# is the target language. And we've been documenting things as long as we go. And also, as I alluded to previously, we do want to compare this to other solutions, be them library-based or server-based, for benchmarks. Now, after this wrapper, the next phase was to actually develop a Unity application. So what we have working now and tested is the core functionality. So that means enabling modules in OpenISS, like getting color data, IR data, depth data, and so on. And we can take this data and actually project it into Unity scenes and render it. For now, for example, we're taking things from the No framework that was presented previously, and we can take that data, like color data, and project it onto geometry. So onto different shapes, planes, or terrains, or even models. And we also have some basic gesture tracking as well. Now, what's left to do, and what our priority is to actually get skeleton tracking done in real time. So we could rig that to a model for motion capture. So have, say, a model move with the movements of somebody in front of a physical camera. And speaking of these cameras, we specifically want to test now with 3D cameras such as RealSense, Orbec, or Kinect. Moreover, the Kinect for Azure that we got through the NFB. So thank you once more for that. And that's what we're going to be working on shortly. Our final goal here is to develop a high-level API and Unity package, meaning that we want to develop a suite of Unity components which are really easy and practical and quite abstract for developers to use OpenISS in their Unity applications, as well as C# applications thanks to our wrapper. And to help guide developers through this, we want to create a suite of tutorials, games, etc., other applications, document all of that, and make it all available for free as a Unity package on the Unity Asset Store. All right, so that's it for me. Thank you.
We have other things going on as well with this. So we work with other devices, with other students. So we're actually multifaceted. So we collaborate and incorporate the functionality from one work into the other, like Kyle alluded, from students on different projects. So in conclusion, we'd like to thank Eloi and Luke for providing the initial advice, requirements, and hardware resources such as Kinect for Azure, and actually pushing us despite our busy schedules every week to progress, and we had quite good progress recently in the last few days with debugging the Windows issues and the DLLs and wrappers and the .NET framework. So we actually were able to finally get the data into Unity. And we got the real production pipeline requirements and with all this survey and stuff like that. And we adopted a nice agile approach. So we used integrated Bitbucket, Slack, and Trello for managing of this project. And that's when we actually started for that. So it helped us to organize. So thank you to the lab and the mentors to make this possible. And as we said, we're working on we're going to be finishing a few things in the next couple of weeks for the real thing to shine. That is all.
So I did a proof of concept thanks to the C# wrapper that Dr. Makov mentioned earlier on. And where we are at currently is a good prototype of the wrapper and some initial data going through. So the proof of concept has been done. Now what we need to do, and what we will do, is create components that are actually doing something meaningful with the data in Unity, and hopefully get, for example, motion tracking to apply on an animated rig where somebody in real time can move and then also animate the skeleton in Unity.
Yeah, my name is David Barlow-Krelina. I'm an animator, technical artist, and sort of, I guess, do a bit of everything in 3D and animation. I've been making films for a while. I made some short with the NFB, Caterpillar Plasti. That was a few years ago, and yeah, for the past few years, I've been with ED Films, also doing a mix of things in animation. We did like just a big projection project with big screens and projections, animation. But yeah, so I'm also getting into VR stuff and doing game engine stuff. So that's yeah, mix of what I do.
Emily Page. I'm one of the co-founders of ED Films. ED Films is an animation studio that's been based in Montreal since 2007. We're a small team that undertakes large projects, multi-year projects, and we are a combination of an art and technical lab. We also do our own in-house development, which is where the garden was born, and we do select services, mostly for experiential, immersive, screen-based experiences.
My NFB XP Lab project focuses on VR as a creative tool and VR as an art medium. When I first started thinking about the NFB XP Lab, I was early in development on my VR project, The Garden. I was interested in exploring VR workflows and advancing my understanding of game engines. The Garden is an interactive animated VR experience that I'm working on as creative lead, produced by ED Films and Red Corner. It explores perception and hallucination in a beautiful and grotesque virtual garden where the user may notice their perceptions morphing, shifting, with feelings like crawling sensations on the skin, strange body proportions, or pulsating landscapes. In the NFB XP Lab, I wanted to explore VR production workflows and techniques used in the game engine to create the animated surrealism of the garden. I'll go over my findings in these two areas, and I want to mention that the visuals you will see here are work-in-progress assets produced either by myself or Artifact 5, who is working with us to develop the prototype for the project. I also want to mention that we receive support from CDRIN through the NFB XP Lab. I'll start with VR production workflows. My question was this: how can VR creation tools like Oculus Medium, Tavori, Masterpiece, Gravity Sketch, and others be used in production? Where do these tools excel? And instead of being used as standalone pieces of software, how might they be integrated into existing workflows, say for someone like me already using Maya or Blender, ZBrush, and Substance? For modeling, I looked at Gravity Sketch and Oculus Medium. Medium, I would say, is probably the closest thing out there to a VR version of ZBrush. It's very intuitive and feels like working with clay. Its voxel sculpting allows the artist to focus on modeling as opposed to thinking about polygons. Gravity Sketch is a little different from Medium in that it's based on strokes. Each time you make a stroke, the program stores that as a unique mesh. The resulting models are not one continuous topology, but rather many separate pieces. I found that having separate meshes makes it a lot easier to select and move specific regions of a model after you've laid them out. One of the great things about Gravity Sketch that I was not able to find in other tools is its layer opacity slider. This comes very much in handy for blocking because you can quickly rough out a 3D sketch, put it on its own layer, and tone down the opacity to use as reference. Here are my findings after having spent some time sculpting in VR. VR is not a precision tool. I found my own art style to have evolved slightly when working in VR. Perhaps something having to do with working in a completely different modality, I'm not entirely sure, but because it's a little bit harder to control, models can sometimes look a bit wonky. Over time, I began to appreciate the look of my models more when I turned off symmetry, as the resulting model tended to feel more interesting and organic that way. VR can be hard to control, but I find that proportions can always be tweaked later on if needed, say when exporting from VR into something like ZBrush. Thin membranes and tube-like structures, limbs, fingers, tendrils are easy and fun to do in VR. This is where VR really excels compared to working on a flat 2D screen. VR is great for blocking. If I'm starting from nothing, I would by far prefer doing it in VR over any other application. In my workflow, I find good old ZBrush still has its rightful place. Fine detailing like creases and pores are easier done in ZBrush. Once the overall mesh shape is blocked in, it's much easier to do precision work with the pen and tablet on a 2D drawing surface. Meshes coming out of VR modeling programs often need a remesh and retopology pass. For animation, there are a lot of tools for animation in VR, but I chose to work with ones that handle character rigs with joint hierarchies. I looked at Tvori and Masterpiece. Masterpiece allows you to rig and animate all in one place, as well as to import existing skin meshes as FBX files, which can then be posed using either IK or FK. Masterpiece sets up IK automatically, and it works in such a way where, if you select and move a bone, it affects the two bones above it in the hierarchy. Tvori is a bit different from Masterpiece in that it comes with a basic rig that can be used as an empty rig. The user can replace the pieces with ones of their own design. I find this rig really excels in its ability to do VR puppeteering, recording movements of controllers in real time as opposed to working pose to pose. Tvori also allows you to import skin meshes as FBX, but the control rig on imported meshes is limited. My findings. Like in modeling, it's difficult to be precise when animating in VR. I found any posing requiring precision, for example, getting the feet of a character to land on the floor without interpenetration, was difficult. I wondered whether having some kind of collision detection or limiters on the up-down axis could help with this. VR puppeteering feels very organic. I really enjoyed the process of recording movements in real time. I found the resulting look to feel really interesting, sort of like stop motion, which would be difficult to achieve through pose-to-pose keyframes alone. I found that animations created in VR through recorded movement could be used in much the same way as motion capture data. The ideal solution would be to create a control rig with similar bone hierarchy in another program, and then to take the animations recorded in VR and retarget them onto it. That way the animator can blend recordings seamlessly with keyframe animation via animation layers and get the best of both worlds. Moving on to tech on the garden. When making a project that embraces surrealism, what techniques can be used in VR in the game engine to give the impression of hallucination and other strange perceptual phenomena as felt in the garden? Specifically working in Unreal Engine and having the Quest and Quest 2 as target platforms. I broke down my exploration of surreal sensory effects into two categories, the body and the environment. Starting with the body. When the user enters the experience, they have a virtual body that moves as if it were their own. Designing this body rig introduced a whole set of technical challenges that unfortunately I don't have the time to go into, so I'll let you gawk at our initial tests that might feel like watching a robot baby taking his first steps. With regards to surreal effects on the body, we found that custom UV channels could be used to create interesting skin crawling effects. We did this by distorting the UVs of the body on an extra channel so that a texture strip could flow through the anatomy of the body if panned in one direction. Sphere masks could be used to give the impression of the body being affected by objects in the environment. We were able to define a point in space and then control texture blending based on how close the user is to that point in space. World position offset could be used to create fluid body effects. There is still a lot I want to explore in this area, as world position offset could be combined with physics constraints to create user-driven body deformation. With regards to the environment, world position offset in combination with a sphere mask could be used to create Inception-style world bending effects. We use this to create huge waves rippling across the landscape. Animated noise textures could be used to create chaos. We use this to create crazy glitchy effects on objects in the environment. These effects will be used in moments of chaos when a user triggers a fail condition or to visually depict the sense that some kind of transformation is taking place. In closing, regarding workflows, yes, VR tools can definitely improve an artist's workflow. I would say these tools really excel in the early blocking stages. Are assets made in VR production ready? Yes and no. It really depends on what they'll be used for, but definitely whatever you make in VR can be optimized or retargeted in other programs and then used in production. Regarding tech on the garden, there is a lot that can be done with shaders in the game engine, more than I ever imagined as someone coming from film animation workflows. I find that creating assets for VR require a lot of careful planning, especially when working on limited hardware like the Quest, but the range of options an artist has to explore are still quite vast. That's all for now. Thank you for watching.
So at this point, we're looking at soft body deformation sort of effects. So in the garden, the user has their own sort of virtual body. So we're looking at effects on how to do deformation using a number of different approaches, using joints, doing sort of vertex displacement stuff in the shader, and some physics-based stuff. And on the process-based aspect of working with VR tools, I've been testing Masterpiece Motion and Tavori, and both as like in the animation process, working with an existing rig. So I'll be going a little bit more into depth into like really getting a feel for one and the other, and this VR puppeteering approach in Tavori is really interesting for me. It's what I'm going to be looking at a bit more.
Sergey, you said that you felt that there was some kind of correlation between the different projects.
Yeah, I found like after I watched all the presentations, the videos, I found a lot of commonality and cohesion between the projects that actually we working on sort of either directly touching or correlated things. That's actually some projects can have further collaborations. I think it's quite interesting because a lot of it involves with animation, sometimes as motion capture, Unreal Engine, in our case Unity, but the same type of technologies, and with music. So I think it all comes together, I think, quite nice. So
I was amazed actually, because I'm seeing what you guys are working on, and I'm like, wait a minute, we could also use this in our instruments that we're making. It's almost like different pieces that could all be working already in cohesion, you know? So yeah, I definitely see a lot of possibilities. I'd love to chat with all of you for more time after this, actually.
In a way, slit scanning in 3D is kind of similar to like drawing in space. Like you can actually capture a motion path, and yeah, the sort of the, I guess, surreal post-apocalyptic look of Alexander's work reminds me of a little bit of some of the modeling stuff I do too. So it's...
For me, what was interesting was like every project had like a different approach in terms of how they decided to do this research. Most of them were like very researched mentality. Like behind the projects, there was like a research mentality. That's what I really liked. And yeah, I was really thinking that I was hoping that if we were together, like in the beginning, maybe we could like exchange a lot and learn a lot and find new directions like during the process. But maybe it's not very late because we still have like a bit of time, I hope.
Mm-hmm.
So, and Parissa, I wanted to say the 2D to Unreal thing is something that we discuss a lot in the studio, and we have a working prototype of a plugin that allows you to bring 2D assets into Unreal. So I'll follow back up with you again when it's ready to be tested. So it's nice to hear your brain is going down that way.
Oh, thank you. Okay, perfect.
Yeah, I think it was tricky because we were kind of developing the engine and just trying to make sure that it was bug-free so that we could actually release it to the public, and then trying to experiment and trying to fit that in, and running quickly into limitations. But you know, that's part of it too. I think working within the limitations, you can get a lot of creative possibilities, and I think we got to a good spot. I think it's for what it is, working just as a sort of a minimal viable version. It's been great, and I think it's just the beginning of something much bigger.
Well, for me, it was really something like it got me to have to learn Blender, to really put my mind to it and not just fiddle with it. So it was a great push for that, and as I say, often it opened a bevy of paths that I'm for sure going to follow.
Yeah, I think like first of it is like when you when you decide to experiment, I think, like especially with completely like a different medium, then you need to accept that you become very amateur and that you're not like, I mean, you need to leave like that kind of professional workflow that you have established for yourself for years.
So I understand the difficulty with which actually, it takes so much time to get used to a 3D drawing tool and to be able to get what exactly the artist has in mind. So I think for us, that's a very good open research problem for us. Why is it that we, in the technology side, cannot create the tools which actually the artist can use the way they want to use it? So I think it opens up many research possibilities.
I think something I find very exciting about it is to get to a point where a virtual instrument is not purely to produce musical output. It's not just a means to an end, but it can be a place you can kind of explore sounds more for yourself, maybe as music therapy or just something fun as a hobby. You don't need to be trying to make a song, produce something. It's just get lost in this musical world.
It's just from even us in the studio working with an imagery instead of knobs and numbers, like it's changed even how we feel about it. And we're getting this kind of reaction too, like, you're working with scene. It's like, seeing a figure or seeing something, moving, that's not just a set of numbers. There's a feedback loop that happens there. So this, even though right now it's static, we see it like once we get into interactive and reactive animations, it's going to just like open up a whole other dimension of creative possibilities. Well, definitely the spirit of the ONFB XP Lab for me is to, experiment for the sake of experimentation without any real need to come up with, with a specific goal. But in the same time, I think that this kind of open experimentation is what is going to allow us to really take it further.
This is a great opportunity to help contribute to the NFB. I mean, NFB has also been like historically responsible for a lot of developments in 3D production for movies. So like fun continuing that tradition, I guess.
The legacy and also the validity that the NFB brings to a project. So Eloi, I think I mentioned this to you, even though the NFB is not directly involved as a co-producer on the project, on an international scale, in the international market, specifically in VR, to have the NFB's stamp of approval, whether or not it's as a co-producer or not, really has helped garner more partnership, more visibility for the project itself.
I think it's a great opportunity for our students to see, okay, if we do some work in the lab, how can we actually move it to the actual practice place? Mm-hmm. So I think this experience is not easy to obtain. I think, the lack of overhead, the ability for our students to interact with professionals, to interact with technical experts at the practical side.
I find it's a very good initiative by the NFB because, it's equipment and like expertise that we can't find easily outside. But at the same time, we know we don't need to apply as a film, to be produced with the NFB, which is a very long process and it's not guaranteed. So actually, I find it very interesting. It's a different type of collaboration with the NFB, which I find very interesting. I hope it continues.
So everything I'm learning through this experience, I'll be able to transfer it, not just in terms of technology, but of knowledge and know-how to future students. So that's what I really appreciate out of this experience.
Taking the experiments that happen often in silo, in small spaces or between small teams, and having the opportunity to experiment and share knowledge, share experiences, and get it out of that place so that it can help others learn from our own mistakes, our own trial and error, so that things can evolve more collectively.
Thank you for watching, and I hope you have enjoyed this video. Please come and visit us on our website and stay connected with our social media to learn about the next edition of our ONFB XP Lab.